Okay, and one more video here, which is the question 5 video. So give the question a quick read. This one is about Bobby and £10 prizes and things like this, okay? So to start with, let's just do the basics. So it says in terms of Q, so the expected value is just going to be 2 times 0.25 plus 3 times Q plus 6 times 0.4. If we do all of that, that's 0.05. No, it's not. It's 0.5. So that's 0.5 plus 3Q plus 2.4. So 3Q plus 2.9. Next, the expected value of x squared. You know the drill. X squared goes in the middle. 0, 4, 9, 16. We can write them again underneath. So we can do 4 times 0.25 plus 9 times Q plus 36 times 0.4. We can even cheat a little bit by saying that's 2 times. That's 3 times. So hang on, not 3 times, 3 times 3, so 9Q. That's 6 times the original amount. So 2.4 times 6 is going to be 14.4. So that's going to be 9Q plus 15.4. Okay. Given that the variance is 3.66, okay, that's useful. So the variance is equal to the expected value of x squared minus the expected value of x all squared. So 3.66 then is equal to 9Q plus 15.4 minus 3Q. Hang on a minute. I'm not going to find Q, am I? Am I? Sure that Q equals this. Oh, yes, I will. It's just the squareds that are going to disappear. So minus 3Q plus 2.9 squared. Okay, so that's a 9Q plus a 15.4 minus, let's put it in brackets, so 9Q squared. So 2.9 times 3 and then times it again. So that gives me 17.4. 17.4. Is that right? Let's just think about that a second. Ah, yeah, okay. So plus 17.4 Q plus what's 2.9 squared? That's going to be 8.41. Okay, and actually it wasn't what I first thought was going to happen. So I get a quadratic here, and the quadratic ends up being 9Q squared plus 8.4Q minus 3.33 equals 0. And when we solve, we get Q is equal to 0.3 or minus 37 over 30. And Q is a probability. So Q has to be greater than or equal to 0. Yeah. So that's our choice, 0.3. So that's quite a lot of work for the first 5 marks, but let's keep going. So we know that Q is 0.3. So let's write that in now. We know that they add up to 1, so this is 0.05. Yeah. Okay, so in a game, the score is given by the discrete random variable x, so we are using this table. Games are independent. Yeah. Calculate the probability after 4 games have been played. The total is exactly 20. So we want to think about the ways that x1 plus x2 plus x3 plus x4 could be equal to 20. Remember, there's never as many as you expect there to be. 0, 0, 6, and then, okay, 0 can't work. There won't be enough left. 2 and a 3 is 5. A 6 and a 6 is not enough. The 2 needs a bigger number to go with it. So 2 and a 6 is an 8, 14. Right, so 2 and 3 6s is a possibility, but then we also have to consider 6, 2, 6, 6. And in other words, you're going to find there's 4 of them. Okay, so we just do the probability of that and we multiply it by 4. So the probability of a 2 is a 0.25 times the probability of 6 is a 0.4, 3 times, and we have 4 of them. So that's the calculation that we're going to do, which is 0.064. So that's the probability that you get 20. Now, a round consists of 4 games plus 2 bonus games. The bonus games are only played if it's exactly 20. So it's this, isn't it? So if you do this thing, which is very rare because it happens 0.064 at the time, then you go into the bonus round. A prize of £10 is awarded if 6 games are played in a round and the total score for the round is at least £27. Now, this is starting to sound very, very confusing, but when you do the 4 games, you go on and you do 2 bonus games. You can't do 1 bonus game or 3 bonus games. So as soon as you're in this 0.064 category, you go straight into these 2 bonus games. A prize of £10 is awarded. Well, if you look, there's no other pound sign, so this is the only place that you can win money. So is awarded if the 6 games can only happen after this. And the total is 27. Well, we know that after or at end of round 4, we know that we get 20, don't we? So we're just looking now at how you get from 20 to at least 27. So you could do a 20 and then what? If you did a 0, you'd still have 20, and even best case, you'd have 26. So that's not going to cut it. So how about if you did 2? You'd have 22, and then you'd need a 6. So we could do, what was that? We could do a 2 and then a 6. Okay, so we could do, so we've got 20 and then, is it x? Yeah, x equals 2 and then x equals 6. So that's one pathway that works. What else have we got? So that was it for 2, wasn't it? Let's try 3 now. So if x is equal to 3, what do we need to break? We need to get at least 27. So another 3 would not do it. So it has to be a 6 again. So x equals 6. And then how about if we got a 6? If we got a 6, a 2 would work. That would be 28. If we got a 6, a 3 would work. Well, everything else is going to work, isn't it? Because it's more. So these are the different pathways that work. So we're going to do, and kind of like the probability attached to this is a 0.064. So that's in the question. Now, these we need to work out, right? So we need to multiply these and stuff. But what we really want to do is we want to find out all of this chunk. They're all mutually exclusive. We want to add them together, and then we want to multiply by that 0.064. That's really what we want to do. And then that tells me the probability of getting at least 27. Okay, I'll read the rest later, but you know that we need the probability of at least 27. So a 2 and a 6, let's zoom out a little bit. So a 2 and a 6 is a 0.25 times a 0.4. A 3 and a 6, well, that's a 0.4. I'm just going to write all my 0.4s really quickly because I know that that's a 0.4. What was 0.25? That's a 2. So what's a 3? A 3 is 0.3. Okay, so let's work these out and let's add them all together. And I've got some stuff on here, so let me just check that this is correct. So 0.4 squared is that one there. 0.4 times 0.3, 0.3 times 0.4, 0.25 times 4. Yeah, great. So that should give you 0.6. So the chance of getting 20 and then getting enough, yeah, is 0.064 times by 0.6, which is equal to 0.0384. That's the probability that you get at least 27 points. Bobby plays 3 rounds. Well, that's all well and good, but the rounds are not games. Rounds just means that you're repeating it. So this is a binomial question. So what is this? I don't even know what letter to use with this. I'll use Y, I suppose. Y is binomially distributed with 3 rounds and 0.0384. At least £10. At least £10 just means at least 1 win. So it just means Y is greater than or equal to 1 using that probability there. Okay? And so when you do this, you will get 0.1108. All right, so tree diagrams, mapping out the ways that things happen, really the way to go forward with these kind of questions.